Okay, welcome to another short video on normal distribution. Like the last video, I will be continuing with some past paper questions that I have here. This is question number 7. Let's start quickly solving this. It says measurements of wind speed on a certain island were taken over a period of 1 year. A box and viscous plot of the data obtained is displayed above, and the values of the quartiles are shown. Now remember that this is the lower quartile. Okay, that's Q1 and that's Q3, and that is the median, which is Q2. Okay, we know from our understanding of quartiles that below the lower quartile, there's 25% of the data. Above the upper quartile, there is again 25% of data, and these are the maximum and minimum values that I have here. Okay, it is suggested that wind speed can be modeled approximately by a normal distribution with mean mu and standard deviation sigma. Estimate the value of mu. Okay, so when I want to do that, now since this is a normal distribution, it is saying it's a normal distribution. You should remember that when you're drawing this curve, um, the highest point at the center is mu. Okay, so we are since it's given approximately by a normal distribution, I'm going to say that for this one mark, there is a value of mu. It's going to be the midpoint of 39 and 63. So 39 plus 63 divided by 2, what does that give us? Let's quickly talk about that. I think that's going to give us 59, but let me just verify. Yes, that is, sorry, 51, not 59, 51 is going to be the correct answer. Okay, then it says estimate the value of sigma. So I could use any of these quartiles or the median and say that I want to find out the value of sigma. So I'm going to say that probability of x less than 39 is 25%. Why? Because it's the lower quartile. I change it to z. So z less than 39 minus mu, which is 51 over sigma, equals to 0.25. So phi of 39 minus 51 over sigma equals to 0.25. 39 minus 51. Why am I carrying this 39 minus 51? Let's estimate. 39 minus 51 gives me minus 12. So phi of minus 12 over sigma. So then phi minus 12 over sigma equals to phi inverse of 0.25. Now remember that when you have a probability that's less than less than 0.5, you can't directly find it from the table. You can see that inside the table I don't have anything that points to 0.25. So what else do I read? I read the reverse. I read the opposite of that. I read 1 minus 0.25 or 0.75 from my table. Okay, so I go and read 0.75 from my table. Where is my table? 0.75 is down here. Easy for me. That's 0.674. I remember this from yesterday as well. So instead of writing 0.674, I'm going to write minus 0.674 because I read the table in a different way. Okay, if you're doing this with the calculator can automatically give you that negative sign. So that solves the problem. So sigma is minus 12 divided by minus 0.64, 674. So I get 17.8, and that is the correct answer. Okay, let's go on to the next question quickly. It says the distance Zotok can travel on 20 liters of fuel is normally distributed with mean 320 and standard deviation 21.6. The distance of the Ganmore car can travel on 20 liters of fuel is normally distributed with mean 350 and standard deviation 7.5. Both cars are filled with 20 liters of fuel and are driven towards a place 367 kilometers away. For each car, find the probability that it runs out of fuel before it has traveled 367 kilometers. Okay, so I'm going to find out if the probability of traveling less than 367 kilometers for both cars in the fuel that I've been given. So Z less than 367 minus 320 divided by 21.6. Let's see if we get a number out of that. 367 minus 320 divided by 21.6. Okay, that gives me probability of Z less than 2.176. Okay, phi of 2.176. So let's read from the table. 2.176. 2.17 is this column, and 6 is to add to. So 9852.9852, and that's the correct answer. So the probability that it's going to travel less than 367 kilometers is 0.9852, and I'm assuming, because the question is worded like that, that the tank of fuel vanishes before that. Now I'm going to use the other car and say that 367, the Ganmore car. So converting it to Z again, 367. This time the mean is 350 and the standard deviation is 7.5. That's the standard deviation higher mean. Okay, so 367 minus 350 divided by 7.5. That gives me probability of Z less than 2.66. No, this is 2.267. So phi of 2.267. Let's read that from the table. 2.267, 2.26, and 7. So 9883.9883. That is the correct answer. It says 0.988, correct to three decimal, correct to three significant figures. Let's do part two. There's more space, but I want to read the probability that a Zotox car can travel at least. So at least is 320 plus D is 0.409. Find the value of D. Okay, so I'm going to convert it into Z greater than 320 plus D. The Zotok car. Where's the Zotok car? It's the first one, which has a mean of 320 only. So I'm going to say minus 320 divided by 21.6, which was its standard deviation. 0.409 here. 0409 or 409. Okay. So I have 320 cancelling out. I have Z greater than D over 21.6, 0.409, 1 minus phi of D over 21.6 equals to 0.409. 1 minus 0.409 equals to phi of D over 21.6. Phi inverse of 0.591 D over 21.6. 591 from inside the table, 591 from inside the table. 591, oh, 0.23, I find it directly. 0.23. And this is giving me trouble every time I do it. Okay, so 0.23 into 21.6 gives me D, which is 4.968. According to me, it should be 4.97, correct to three significant figures, and yes, that is indeed the correct answer. Okay, moving on to the next question now quickly. It says the times taken to play Beethoven's Sixth Symphony can be assumed to have a normal distribution with mean 41.1 and standard deviation 3.4, three occasions. So there are three trials on which the symphony is played are chosen at random. Find the probability that the symphony takes longer than 42 minutes or to play on exactly one of these three occasions. I'm asking you the probability of one, and my success is this. Okay, my success is that it should take greater than 42 minutes. So Z greater than 42 minus 41.1 divided by 3.4 equals to success. Okay, so 42 minus 41.1, 265, 1 minus 5.265. Okay, it's 0.265 from my from my table. 6026 plus 19 is 3545. 6045. 6045. 0.3955 is my success. Okay. The probability of then one occasion out of three, so 3C1, 0.6045 power 3 minus 1, and 0.3955 power 1. 0.4336 in my case, because I've taken an exact value. It says 433 here. I'm getting 434. That's a little rounding off. That doesn't matter because my answer is more accurate. Okay, then it says the times taken to play Beethoven's Fifth Symphony can also be assumed to have a normal distribution. The probability that the time is less than 26.5 minutes is zero point 0.1. Okay, so probability of x less than 26.5 is zero point 0.1. The probability that the time is more than 34.6 is 0.05. Find the mean and standard deviation to play this symphony. So I'm asking you for the values of mu and sigma. So this is basically a simultaneous question. It's going to take a bit of time and a bit of working. So let's write it properly here. X is less than 26.5 is 0.1 and 34.6 is 0.5, 0.05. So I start off, I say 26.5 minus mu over sigma equals to 0.1. Phi of 26.5 minus mu over sigma equals to 0.1. 26.5 minus mu over sigma equals to phi inverse of 0.1. Okay, phi inverse of 0.1. From the table, it's going to give minus 1.282. So 26.5 minus mu over sigma equals to that, minus 1.282 mu, 282 sigma. Then probability of z greater than 34.6 equals to 0.05. Sorry, not greater than 34.6, 0.6 minus mu over sigma equals to 0.05. Then it's 1 minus phi of 34.6 minus mu over sigma equals to 0.05. 1 minus 0.05 equals to 34.6 minus mu over sigma 0.95. 34.6 minus mu over sigma. That'll phi on it. Phi inverse of 0.95. 34.6 minus mu over sigma. Okay, so what's phi inverse of 0.95? Let's look at our table. It's easy to calculate from down here. 1.645. So 1.645 sigma. And I'm going to move mu to this side just to show you some calculations later on. Okay, I'm also going to convert this into the simultaneous that I have there. Okay, so I have a pair of simultaneous equations now. I have 1.645 sigma plus mu equals to 34.6 and minus 1. 282. Sigma plus mu equals to 25.5. I change the signs and I eliminate. What's 1.645 plus 1.282? I have 2.927 sigma 34.6 minus 25.5. 9.1 sigma equals to 9.1 divided by 2.927. I'm getting 3.109. So 3.11. Let me check if that is the correct answer. It is telling me it's 2.77. I may have made a mistake somewhere. Let's check my mistake. I think I've changed 26.5 to 25.5. So let's change that back. It's 8.1. It's 2.77. Okay. That was what the question is also telling me. It's a small error, but costly because I'm going to lose both the answer marks here. 2.7. It's 77 plus mu equals to 34.6. I'm trying to find the value of mu. 645 into 2.77, 34.6 minus answer. So mu equals to 30.0. Yes, that was what was in the question, so I am correct. Let's look at part 3. It says assume that the times to play the two symphonies are independent of each other. Find the probability that when both symphonies are played, both of the times are less than 34.6 minutes. Okay. Assume that the times to play the two symphonies are independent. Find the probability that when both symphonies are played, both of the times are less than 34.6 minutes. For the second one, I already have more than 36. So I'm going to say that second one less than 36 is 0.95. Okay. For the first one less than 36, do I have that? No, I will have to calculate that. What's the probability of x less than 36? I don't know why I have calculated 36 when it was 34.6. This all of this is wrong. I am rushing through questions, which is why this is a problem. It's 06. Okay, let's check 1.806 from here. Nine six four five, I think. That's 0.0355. Let's check if we are still getting the right answer or not. 0.0355 multiplied by 0.95. I'm still not getting the right answer. Assuming the times to play the two symphonies are independent of each other, find the probability that when I've again done a very silly mistake, and because this is 3.4, all my answers are again wrong. So I get minus 1.91212. Okay, what's 1.912? 972. 972. 0.028. So point 028 into 0.95 gives you, yes, 0.0266. Okay, let's move on to the last question then. Question 10 says, once a week, Zach goes for a run. The time he takes in minutes. So this question says, once a week, Zach goes for a run. The time he takes in minutes has a normal distribution with mean 35.2 and a standard deviation of 4.7. Find the expected number of days during a year, 52 weeks, for which Zach takes less than 30 minutes for his run. Okay, so I want to calculate first the probability of less than 30 minutes, and then I want to calculate an expectation, and I'm going to look at that in a bit. So z less than 30 minus 35.2 divided by 4.7. Let's not make any calculations error this time. 30 minus 35.2 divided by 4.7. I am getting probability of z less than 1.021 minus 1.021. 30 minus, let me just do this again. Minus 1.106. Okay, 1.106 from my table. Eight six five five. Okay, so phi of this 8655. So 1 minus 0.8655. That gives me 0.1345. There's once a week Zach goes for a run. Okay, he goes for a run once a week only. Find the expected number of days during 52 weeks. So what I'm going to do is I'm going to multiply 0.1345 by 52. I am going to get 6.99. So 6.99 is the expected number of weeks, and every week he goes for a run only once. So that is also the expected number of days that he takes less than 30 minutes. Okay, the probability that Zach's time is between 35.2 and t minutes, where t is greater than 35.2, is 0.148. Find the value of t. So I think that's simple. Probability of 35.2 minus 35.2 divided by 4.7. Z t minus 35.2 and over 4.7 equals to 0.148. This becomes 0 z t minus 35.2 over 4.7 equals to 0.148. Okay, so phi of t minus 35.2 over 4.7 minus phi of 0. Phi of 0 is 0.5. 0.148. 0.648. T minus 35.2 over 4.7 equals to phi inverse of 0.648. Okay, 0.648, again from inside the table I'm reading in reverse. 0.648, there it is, 0.38. So T minus 35.2 over 4.7 equals to 0.38. 0.38 into 4.7 plus 35.2 gives me T, which is 36.986, approximately 37. Okay, so that was part 2. Part B then says a random variable x has the distribution this. It says that the probability of x less than 7 is 0.2119, and probability of x less than 10 is 0.67. Find the values of mu and sigma. So this is like last time where I solved simultaneous equations. It's going to be pretty much the same. 10 minus mu over sigma equals to 0.67. So phi of 7 minus mu over sigma equals to 0.2119. 7 minus mu over sigma equals to phi inverse of 0.2119. Now since this value is less than 0.5, I can't read this directly from a calculator. What will I read instead? I will first subtract 0.2119 from 1 and read that and put a minus with my answer. So I'm reading 0.7881. I have a feeling that should be a direct number. 7881. 7881, that's 0.80. So 7 minus mu over sigma equals to minus 0.80. 7 minus mu equals to minus 0.80 sigma, and 7 minus mu equals to 7 equals to minus 0.8 sigma. Then the next one is 0.10 minus mu over sigma, 0.67. 10 minus mu over sigma equals to phi inverse of 0.67. 0.44. Okay, 0.44 sigma, 10 equals to 0.44 sigma plus mu. Okay, plus mu here as well, sorry. So 7 equals to minus 0.8 sigma plus mu is the other simultaneous equation. This is equation 1. It's equation 2. Let's change the signs and solve. I think we should get our answer. 1.24 sigma. So sigma is 3 divided by answer 2.42. Yes, I got it right in the first go this time because I'm not making silly errors anymore. Okay, so then 7 equals to minus 0.8, 2.42 plus mu. I get 8.93. Okay, let's look at these in the next video then. I think that is a long enough video for you to practice. Please make sure to like, subscribe and comment if you liked the video, and please follow for more. Thank you for watching.